Hey, this is Nick with a review of some items from BGMicro. I got some breadboards. These were $1 each. They're relatively good quality. The pads are pretty much in line with the holes and there's not much flash. They seem pretty sturdy, not like the cheap paper ones. Next, I got some 20-pin sockets for hooking up to standard pin headers. These were 4 for $1. What's kind of neat about them is that the pins are bent out at an angle on either side, so it makes it easier when you go to solder because there's more room around each pin. I also got this chip puller. This was 80 cents. At first it looked like it was meant to be used from the side, but it doesn't fit. Then I realized you're supposed to use it like a regular one and it's just kind of wide. Kind of inconvenient for smaller chips, but works okay. This item is a set of 3 old UV erase EEPROM chips. It was $3 and change for this. You get a 4K, 32K, and 128K chip, as well as an adapter board. I think this board was used with some specific software to let you plug the 128K chip into a 32K socket. There's a 13 input NAND gate and a counter, as well as some machine pin sockets on this board. EEPROMs and their modern flash equivalents in the PDIP package normally go for a lot more than $3, so I'd say this is a good deal if you have an old computer or arcade machine that needs one replaced. Finally, we get to the most interesting item, a big surplus PCB full of chips. This was $4. Now, for reference, BGMicro offered to break these boards down to save on shipping costs. I took them up on this, and as you can see, somebody obviously just snapped them in half by hand. So, if you're worried about anything being damaged, you might want to pay the extra few bucks for shipping. There's not too much to say about the board itself. From what I can tell, it looks like it was made in the mid-90s by Fairchild. I got 2 of them to compare differences, but it looks like they all have the same parts. It's impossible to see how anything is connected, as both the top and bottom layer are ground planes. So, let's take a look at what chips we get. These are 128K static RAM chips, 7 of the same part number. It's not common to find this size of RAM in a PDIP package. Usually it's all surface mount by the time you get to this capacity. 128K might not seem like a lot, but it's plenty for an audio or music buffer or a frame buffer for a crude video card. Having several of the same model also opens up projects that use multiple chips in parallel, such as a 16 or 32-bit DIY logic analyzer. Another static RAM chip, this one's only 32K, not a lot of memory to work with, but I think worth keeping as a spare if you work on old computers or game consoles, since it's a common Hitachi part number. There's a Motorola CPU, an Altera FPGA, and a CPU clock generator. These parts all require pretty extensive knowledge of old hardware and software to get them up and running, so unless you've worked with something similar, you probably won't get any use out of them. These are a couple of 4K UV erase EEPROMs. I assume one is the configuration for the FPGA and the other is a program for the Motorola CPU. Unfortunately, my EEPROM reader doesn't like 4K chips, so I can't show you what's on them. We've got some standard 74 series logic, there's a hex inverter, and some NAND gates. I tested the inverter with some crystals and it looks like it'll do at least 20 MHz. These are 74HC245s. You can use them as level shifters to drive 5-volt logic from 3.3-volt microcontrollers. These are 4117s. They can act as pull-up or pull-down resistors that can be toggled via logic. These are 74HC374s. Very handy for output expansion on microcontrollers. A single one of these can store the state of up to 8 I/O pins. So, for example, if you wanted to control an array of 32 LEDs, you could connect 4 of these together and only need 12 free output pins to control them all. These chips here are 3 to 8 line decoders. So you send them a 3-bit binary number and get one of 8 decoded outputs. You could use them to select a row or column of an LED matrix, or to enable a specific RAM chip in a bank. The only non-usable parts are these Altera programmable logic chips. They're not erasable, and we have no idea what they were programmed to do, so without an expensive chip analysis tool, these are completely useless. So, overall for $4, I'd say this is definitely worth it. Alright, that's it for this review. Keep an eye out for more videos coming soon.